So welcome to using MySQL Document Store with Node.js. As Brent said in my obligatory I love me slide, I'm a developer advocate for Oracle. I've been a developer for over 20 years. The only thing that's remained constant in my development stack in that time has been MySQL. I'm an avid golfer, and even after last Sunday night's performance, I am a diehard Giants fan. And this is my dog Murphy, who is the best office mate anybody could ever have. He's a 110-pound Labradoodle, and he likes nothing more than to be as close to you as he possibly can. So what are we going to talk about today? I'm going to give a brief description of some of the differences, some of the pros and cons between NoSQL and relational databases. I'm going to give you a high overview of what MySQL Document Store is. I'm going to break down the anatomy of what MySQL Document Store is. Then we're going to talk about how you connect a Node application to Document Store. I'm going to give examples of using the CRUD API, and then I'm going to give an example of using raw SQL in Node to actually hit information, return information from your documents in Document Store. So NoSQL versus relational data. I come from the school of thought that all data needs to be strictly structured in tables with columns and having foreign key relationships and all that stuff. It took me a long time to get on board with NoSQL because my brain couldn't wrap itself around that. But I do think there are some places where you have an advantage. When you're dealing with NoSQL, you can have faster development time. Why? Because if you have to change your schema, you don't have to have that schema change developed by somebody else if you're on a project with a DBA. You don't have to wait for that change to be propagated through all the different tiers of your development process that you might have. All you need to do is just add a new property to a JSON blob and bam, your schema has changed. And it's pretty easy to use. Almost every NoSQL solution out there, and I say almost every because I haven't used them all, has a very basic CRUD API that's used for saving and retrieving information from JSON documents. Some of the cons, the data isn't structured. And that might not necessarily be a con depending on what the data is, but it's difficult to run queries for reporting or for analytics. Some of the pluses for relational data is the data can be structured and organized. It's very easy to look at a well-developed database, or I should say a well-architected database, and know what data is where. And it's easier to run queries for reporting. You just run select, blah, 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 whatever. Some of the downtimes are there could be slower development time. Again, if you're on a project with a DBA and a change needs to be made to the schema, that's not going to be as quick as you probably need it to be or want it to be. And as more data gets added, as more related data gets added, CRUD operations become much more difficult, much more complex in scope. So what is MySQL Document Store? It is a JSON document storage solution that is built on top of MySQL. So it's technically not a NoSQL, it's just the developer doesn't, it's NoSQL for the developer, but SQL still is executed. The documents are stored in a MySQL table using the InnoDB storage engine. Because of that, MySQL Document Store is fully ACID compliant. It uses the JSON data type, the native JSON data type in MySQL to store the JSON documents. And like the other NoSQL solutions out there, it has an easy-to-use basic CRUD API for storing, retrieving, updating, and deleting documents. So how many people here have used NoSQL before? All right, good, a lot of you. That's good. Last time I gave this lecture, it was like nobody. So when you're talking about NoSQL, the nomenclature is slightly different. So for the people who are more database-minded, when you talk about a schema in NoSQL, it's the database or schema, depending on which database you're using. A collection is similar to a table, and a document is similar to a row inside of a table. When you create a new collection in MySQL Document Store, by default, three columns are created in the table. The ID, now when you add a document to your document store, if the document has an _ID JSON property, then that will be used in this column. If it's not, it's auto-generated. And when it's auto-generated, it populates this column, and it adds the underscore ID property to the JSON document itself. Then we have doc, which is where the actual document itself, and it's the JSON data type. And then there's JSON underscore schema, which is again the JSON data type, and that's actually used to validate JSON documents when they're inserted into the document store. Why do we want that? Well, while yes, it's great that we have schemaless stuff, sometimes you might have a situation where you need to make sure that a particular property in a JSON document always exists, or that it's always a particular data type. And using the JSON underscore schema, you can actually validate any document that you dump into that collection. How do you access MySQL Document Store? Well, there's a thing called the X plugin, which sounds really cool and neat, but it's really not. There's nothing you need to do to run MySQL Document Store if you're running MySQL higher than version 8.01. Since 8.01, it's been installed by default. The only difference is instead of communicating on port 3306, it communicates on port 33060. So you might need to do some infrastructure changes to allow that port through your firewall. It uses the X protocol, which we have officially supported connectors. Connectors is the internal name, and I hate it. Don't tell anybody I said that. They're SDKs is what they are. And we have connectors or SDKs for Java, C++, Python, PHP, .NET, MySQL Shell, Node.js. Those are the ones that Oracle officially supports. There are also community-supported connectors for Rust and Go that work with Document Store. So during this presentation, I'm going to show you a sample application that I wrote that shows how we can interact with MySQL Document Store. And really, it's just a basic, simple demo of how to use using a REST API. It was built using Express. It contains just two files. Index.js handles all the routing, and then Document Store.js is a class that actually handles all the communication with MySQL Document Store. And it uses environment variables for the database connection information. Schema kind of looks like this. Mentioned before, I'm an avid golfer. I actually manage a golf course. I'm sorry, not a golf course, a golf league. And I have done so for about 15 years. And after a couple years of doing it on Excel spreadsheets, I decided I wanted to do something different. So I actually wrote a web application that I use to manage the golf league. We have 80 golfers that play every year. And this is data extracted from that application. And each document in our store is a round of golf that somebody played. And that information includes their name, the date, what their score was, what the golf course was, and then their individual scores on each hole. So this property right here, hole scores, that's actually an array of objects that includes what the golfer shot on any particular hole on that particular round. So I want to give you a warning. The Node portion of this code, I would say, is not production ready, mostly because I wrote it on the fly, and it's really the first Node application I've ever written. So anybody here who's going to be like, I can't believe he did that, please come up afterwards and say that. Don't bring it up in front of everybody. So installing the connector is pretty easy. You do npm install at mysql/xdev API. Yes, I know the name sucks. Can't do anything about it. I already talked to the engineering team. So in our index.js file, we import the document store class using the import statement, and then we create an instance of that class, and we pass in information that we'll need. The database user, the database password, the database host, which is the IP address, database port, the database name, which is actually the collection name we're going to use. I'm sorry, no, the DB name is the schema, and then the collection name. That all gets pulled in from the environments variable and creates the instance. And you know what? I forgot something. Let me go back here. So those of you who didn't win a second time, actually I can go forward. When I'm done, I'm going to give away one of these plushies. It's a MySQL dolphin little stuffed animal. You'll have to answer a question at the end of the presentation. And the question is going to be pertaining to the content on the slides as we go through, so you got to pay attention. At the end, only one guess per person. Okay, so now we're in Document Store.js. We're actually in the class file, and we're going to break down the code on how we actually import everything and use everything. So the first thing we do is we import star as MySQL X from the plugin. And that's our constructor. I'm going to break this down in smaller bits of code. So initially you see we're actually expecting arguments that are the user, password, host, port, database name, and collection name that were pulled in from the environment variables. Then we create private variables named database name and collection name. We're going to need those for some examples later, and we set those to the values that were passed in. We create a connection string or a connection URL where we specify we're using MySQL X, which is the protocol that we need for Document Store. Pass in the username, the password, the host, the DB port. Again, remember by default it's 33060. And then the DB name. And that's in there so that when we make calls using SQL, we don't have to specify the table name. And this last part, what we do is we set up a connection pool. So it's easier to grab sessions from the connection pool. And in this particular case, the properties that are passed, we're saying we're enabling the pool, the max size is 10, the max idle timeout is 20 seconds, and the queue timeout is 5 seconds. In this particular case, we're never going to hit any of those in this example. So now we get into the CRUD API. So this is in index.js where we have a route set up where we're like, we want to list all the golfers. So you can see we actually call docstore.listAllScores, and then we return it as a JSON object in the response. Inside of documentstore.js, this is what the function looks like. The first thing we're going to do is we're going to grab a session from the connection pool. Then we're going to grab the database, we're going to grab the schema from the session. And then we're going to grab the collection from the schema. Now, pretty much every example I'm going to use from here for the rest of the time, those first 3 steps in this method are the same. They're going to happen every time. Then we call collection.find. Collection.find is doing select star from, okay? When you have an argument in the find method, that's like adding a where clause. So without any method being passed, find is select star from table. And then we call .execute on that to get the results. To get the data, we have to do fetch all on the results. Another important thing we need to do is close the session, because that can cause issues. That's also going to be the same in every other example. And then lastly, we return the data. So to show you what that looks like, you can see in this data set I have, why isn't it? Oh, there it is. In the data set I have, there are 14,879 documents. And that actually returned it pretty quick, and most of that delay was Insomnia trying to render it. So the results actually came back pretty quick, and that's actually running on a database that's on my laptop. So you can see that also has all the information that we talked, and you can also see if you look at the date, this is from last Thursday. So this data has all of the most recent scores from our league. So obviously there's going to be very few times when you're going to want to do give me everything. You know, we're often going to want to limit that, usually through some type of pagination. With that, we can use limit and offset in the find method. So here you can see we have a route set up, again this is back in index.js, where the limit is required and the offset is not required. And then we pass both of those parameters into our call to limit all scores. Again, we take the results and we return it as a JSON object. So inside of limit all scores, the first thing I do, I say, hey, if offset doesn't exist, set it to 0. That means we don't want to have an offset. Now, something that I like about the way this is implemented is I always had a hard time wrapping my brain around offset because some database systems, they kind of do it a little bit differently. For this particular implementation, offset means the number of rows you want to skip. Sometimes the offset is the row you want to start with. So if we want to start with row 11, the offset would be 10. So you see in the for item number 3, we're still calling collection.find, so we're still saying get everything, but now we're saying, excuse me, now we're saying limit it to the particular number that was passed in and offset X number of records if the offset was passed in. So we go back to here, and here I have an example where I'm limiting the results to, oops, that's not it. I'm limiting results to 100. And if I hit send here, no. You can see that the count now is 100. So this is going to have the first 100 items. And to show that I'm actually offsetting correctly, I'm going to offset it by 2,000. So here you can see it's still 100, but if you look at the date, it's from last year. So that's like an easy way, I think, to do pagination when you're dealing with Document Store. Now, also, there's going to be times where you're not going to want the data returned to you in the order that it was put into the database, which is what happens with Document Store. So the documents that were the documents that were inserted first are the ones that are going to be at the top of the result list if we don't sort it. So here, what I did here is I set limit to be an optional parameter, and I basically say if the parameter doesn't exist, set it to 50. So no matter what happens, if you say there's no limit, it's still going to limit it to 50. And we pass that into the get best scores method. Now, there's also going to come times where you're not going to want to return every property in a document. Some documents can be huge, like I'm talking megabytes worth of space or worth of text. And you're probably not going to want to return that all the time. We can actually call the fields method. Now, the fields method takes an argument in 2 ways. If you only want to return one property or one field, you can just pass the string with that property name in it. If you want to return more than one, like we are here in the example, you pass in an array. So here you can see all we're getting back in this example is the first name, the last name, the score, the date, and the course object. And then what we want to do, because we want the best scores first, we're going to sort that. And again, sort is the same way. If you only have a single argument in your sort, you can just pass the string. But here we want to say, I want to show all the score. I want to show the lowest scores first, but if we have rounds where the score is the same, I want to show the most recent one first. So we're doing sort score ascending and then date descending. And score and date in those particular cases, those are actually the names of the properties in the JSON blob. Oops. Got to show you that. So now we go to the best scores, and when I click send, so now you can see there's a lot less information involved because we're not pulling back all the information for the holes that the golfer shot on that particular round. It's just the limited information that we wanted, and this would probably be much, much easier to work with on the front end. So now we're going to get into the where clause when you're using find. And as I said earlier, when you use find, what we're basically doing is we're passing in a where clause that's going to be used on the back end. In this particular case, we're not accepting any user input. All we want to do here is we want to return all the rounds that have ever been played that are under par. And you see here by item number 2, we're passing in a string that says score is less than course.par. Now, course is also a property in our JSON object, like I showed earlier, and par is a property on that object. So in this case, we can just use a dot delimited path to say I want course.par, and if there were other objects underneath that, we can continue that dot path to get to the property that we want. And something else that's interesting here is if you note here under fields, we're not going to be returning the entire course object. We're going to be returning just the name. So we can actually say in the fields, we don't want course, we don't want just the whole object, we want course.name. Here's something to keep in mind though, you have to alias it or else you're going to get some wonky results. If I didn't have the as course name here, the property that's returned would actually be course.name, which again could cause some wonkiness. So if we look here for the rounds under par, you'll see there's 152 rounds under par, and the last one was on Tuesday, September 5th of this year. In this particular example, we're going to talk about how you bind data. Everybody here should be aware of the fact that when you're taking user-provided data and plugging it into a database, it needs to be scrubbed. If you don't know that, learn it. It's very, very important. So here, an example, basically we say get by score. If score doesn't exist, we set the default to 36. And in get by score, in the find, we have score equals colon score param. The colon parameter name is how we parameterize the data. And then we call dot bind, and we pass in the parameter name and then the parameter value. So in this case, we're saying set the score param equal to whatever value is passed in, and then the where statement then becomes score equals where the score that was passed in. And notice number 4. When we list out the fields, we can actually use MySQL functions in the field list. What we're doing here is we're concatenating the first name, a space, and the last name, and we're returning that as a property named golfer. And you see how that works. So here, this should default to 50, which it did. And I put that in there because I knew I was going to be at the top of the list. Yes, I'm not happy about the fact that in the last day of the golf season this year, I shot a 50 on 9 holes. That's not a good score for people who don't play golf. It's not a good score at all. And something about this data. I'm going to have links to the GitHub repo and stuff. This data is already there if you want to play with it. All the names have been anonymized except mine. So anytime you look at this data and you see my name, that was actually a round of golf that I actually scored. Please don't hold it against me. I'm going to show you another example of bind using a like statement. And the reason why I chose this is because of how we need to keep in mind what we're dealing with when we're writing some of these statements. So here we have get by golfer where we pass in the last name. If the last name doesn't exist, we pass in an empty string. Now here's where it gets interesting. If you look at number 2, it says we're doing find lower last name like last name param. That's a MySQL function. The lower there is a MySQL function. So what that's doing is in the where clause, it's taking the last name of the golfer and it's making it all lowercase. Okay? In the bind, you see we're doing last name to lowercase. Why? What was that? Because it's in JavaScript. We're dealing with JavaScript then, not MySQL. So here we're saying the last name the last name parameter is the last name value passed in to lowercase, and when you append a percentage sign on the end, so we get it. So that's how it becomes a like statement. So if we go back here, do get by golfer, whoops. And here, these are scores. Now the name is a friend of mine. Raymond Camden is a good friend of mine. He doesn't play golf, so I just substituted his name in there. And you can see there's 86 rounds, and it has all the information that we returned. Group by. Sometimes you don't want individual data. You want stuff grouped together. So the example I gave here is I wanted to figure out what is the average, the minimum, and the average, the highest, and the lowest scores that were shot at any one of the golf courses that we played. Oops. So here, we're doing some field stuff again, where we're doing, so we have the average score, we do average score, and then we round it, and we have count score, so it tells us how many scores there were. And then you see the wonky stuff in the min and the max. That's because of a bug that exists right now in the MySQL optimizer when you're using Document Store. It's been reported. I checked it as of this week. It still hasn't been fixed. What winds up happening is if you don't cast it as an unsigned, it actually returns it as a string. So if you're expecting numbers and you get a string and you try to sort it, you get some really weird stuff. Like the min score was 110. That's not the case. And then you see the group by. We're just grouping it by the course.name. Okay, so this could have been a single property, or I'm sorry, this could have been just a main property off the root, or in this case, we're doing it off of the name property on the course. And then if we do that, get course data, whoops, you'll see that this data is only for the front 9 and the back 9 at Locust Hill Golf Course, which is the golf course that's closest to my house. And you'll see that for the average score on the front 9 is 46.57. The lowest score is a 29, and that's not a typo. I was actually with the kid when he shot a 29. That was last year. The highest score was an 89, also not a typo, and I did have to go back and verify that that was an 89. Again, that's for 9 holes, not 18. 89 on 18 holes is pretty good. 89 on 9 holes is dreadful. And the number of rounds was 7,704, and you can see the same information for the back 9. Oddly enough, the 31 is the same kid who shot the 29, but not on the same day. He's pretty good. He plays college golf. So now we get to an example that I think is probably the thing that makes MySQL Document Store a little bit easier to use than some other NoSQL solutions. As I said before, sometimes if you have JSON documents, you might want to run reporting on the data that's in there, or do some type of analytics. And with other NoSQL solutions, it's difficult to do. It's not impossible, but it can be difficult. So here, the idea I came up with here, this is one of those shower thoughts. When I was putting this presentation together, I was trying to think of cool things that we could show. And I actually thought to myself, what if I tried to figure out the lowest score that would have been shot using the best score recorded on every hole, regardless of the golfer? So this is about 14 years of data, taking every hole into account, taking the lowest score on that hole across those 13 years, and then adding up those 9 scores to see what the best score would be. I was shocked by the answer. Oops, I'm not there yet. Hold on. All right, so this is how we did it, okay? Now, I know that looks like a lot, and I'm going to break it down. Don't worry. So the first thing we start off with is we start off with a common table expression. For people who are not familiar with common table expressions, I have 2 things. 1, they're awesome, and 2, they are a little bit difficult to wrap your brain around initially. Essentially, a common table expression is nothing more than a temporary set of data in a query. So it's kind of like, you can treat it like a table, but it's not a table because it actually has data from within the actual query itself. The second thing we see is we're using a function called JSON table. JSON table is a built-in JSON function in MySQL that allows you to treat an array of data as a table. I'm not going to break down the syntax completely, but basically what we're doing here is we're taking the whole scores data for each golfer, turning it into a table where we have the score and the whole number. And then MySQL does a natural join on that table inside of this little query here. So we can actually say, I want the min and I want the max score for each thing, and then we're going to group it by the course and then the whole number, and we're going to order it by the course and then the whole number. Now, the second part of this is we already have our common table expression, so we're going to start pulling information from our common table expression rather than pulling it from the database. And we're using another JSON function called JSON object. JSON object is a way that you can create JSON objects in MySQL. It takes groups of 2 arguments. And those 2 arguments are the property name that you want and the value you want to set. So here, all we're returning is the course name and the best score, and the value of the best score, we're summing the min score for that particular course for all the holes. And you see the from is from ag scores, which was the name of our common table expression. And then we do group by course, order by course. Now there's a little bit of difference here. This is one of the examples where I'm not pulling in the session and the schema and the collection. All I'm getting is the session. Because when you're dealing with raw SQL with Document Store, you don't need to worry about the schema and the collection. You just do session.SQL, you pass in your SQL that you want, and then you do the results equals query.execute. Okay, again, you still need to do the fetch all, and then again, close the session. So now I'm going to show you the example of this. So for people who are familiar with golf, there are usually 18 holes. We only play 9 holes. The best, if we took the best score ever recorded on every hole and added them up, 20 would be the total score of both the front 9 and the back 9. Now what that means is every hole on this golf course has had an eagle at least once, and an eagle is 2 strokes under par. Every hole except 4 of them, which is pretty good. And it's funny, I asked people in the golf course if they can name all 4. Nobody could. When I saw this result, I'm like, I got to figure out which 4 holes they were, and I was able to pick them out with no problem. Nobody else could do it. So adding documents is actually pretty innocuous. You see here that we're using post here instead of using get like everything else. And then when we call add score, we pass in the request body. Why do I keep wanting to do that? And in the add score function, there's the stuff on top where we get everything like, the session and the schema and the collection. And then here we just call collection.add. And we pass in the data that comes through it. Yes, I know this is not being scrubbed. We should probably bind this, but I didn't. And I have a little bit of error handling in here that says, hey, if there was a problem, just return, that it didn't work. So when we do add score, you can't see sorry, we can't see that, but it says success equals true. There was actually a JSON blob in there that I added. And we do verify add, and we can test to see that it was actually added. I'm a little bit behind it. I apologize for that. What's that? 2 minutes? Okay. Modify, basically if you want to modify an existing structure, you'd use the .modify. So here what we're doing is, in the previous example, we didn't provide the whole scores array. In this example, we're going to add it. So we say modify ID equals ID param, whole scores equals the data that's passed in as the whole scores. I'm not going to show the example of that, just because we need to get through. And then remove. If we want to remove an object, all you really need is the ID. This is just some, again, some attempted error handling I did here. When you call remove score, we do collection.remove. We pass in the ID and the param, and then we have the bind there. Something to keep in mind with modify and remove is Document Store will not let you do any of that operations if you don't have a where clause. So you actually have to pass an argument to modify and remove, or else it will modify everything or remove everything. Okay, recap. I'm not going to do that because you already heard me. If you guys want the resources, get your phones out. Nobody wants them? You guys are good. Don't put them away. There's 2 more. This is the GitHub repo. This is the MySQL Store documentation. Oops, went the wrong way. Sorry. This is the documentation for using the Node connector. So all the code that I did inside of our class there is where you get information for this stuff. This is how you can contact me. Scott.stroz@oracle.com is my email address. On LinkedIn, it's Scott-Stroz. And on Twitter, I refuse to call it X. On Twitter, it's Boyzoid. And lastly, When we go to conferences, we actually offer attendees who are at the conference come to our sessions. If anybody's interested in getting credit to take a free certification exam for MySQL, see me outside after the session is over, and I can tell you what I need from you and what you can expect. Any questions? Sorry, I went through that a little fast. My timing got a little off in the beginning. I apologize. I'm sorry? What's the 4 holes? 4 holes? It was 11, 18, 4, and 1. And those are, I actually gave you those in the order of difficulty on the course. Okay, so it's time for Scott's giveaway. Remember I told you in the beginning you were going to get this, and you had to pay attention to the slides? There are a number of slides that I showed you that had a picture of my dog Murphy. How many were there? No, it wasn't 2. 4. There you go. There were 4. And thank you for whoever picked it up. I did that on purpose. Thank you, everybody. Wait, hold on. Don't everybody go. Stay where you are. I need a picture. All right, come on, cheer. Look like you're having a good time. There we go. That was pretty, I mean, they put their hands up, but the audio was kind of weird. The video was good, the audio not so much. Thank you, everybody.